This screencast is about the VSEPR theory, or the VSEPR theory, and in that theory it describes the shape that molecules will take. We've learned that different molecules take different shapes depending on how many electrons they have, how they're being shared, and how many elements are attached to that central molecule. So the VSEPR theory describes the molecular geometry, and the molecular geometry is a three-dimensional arrangement of a molecule's atoms. Depending on whether the electrons are shared uniformly or not will determine whether it's a polar bond. So if the electrons are shared symmetrically and evenly throughout the whole molecule, that is considered nonpolar. But if the electrons are not shared evenly and they are around one end of the molecule or not, then that's polar. And the polarity will influence the characteristics of the different molecules, whether you have a solid, liquid, or gas. It'll have different forces that act between those two molecules so when they're side by side. Okay, so back to the VSEPR theory, the VSEPR theory. It says what it stands for is valence shell electron pair repulsion. So we know that electrons are all negatively charged, and if you have electrons around your elements that are attached in your molecule, there's a good chance that these electrons will be close to each other, and by having all negative charges, they act like the north end of magnets. And if you put magnets side by side with the north ends near each other, they'll repel. Electrons do the same thing. So when you form a molecule, whether it's three-dimensional shape or linear or whatever it is in a straight line, the position of the attached atoms will shift slightly depending on how many atoms are attached to the center and how many electrons you have there. And so what happens is that you make various three-dimensional shapes. So I have here it says the VSEPR theory states that the repulsion between the sets of valence level electrons surrounding an atom causes these sets to be oriented as far away from each other as possible. So you get different shapes. You can have shapes like a straight line called linear. You can have a shape that's bent. You can have a shape that is trigonal, planar, or tetrahedral, just to name a few. Now we will get into these names further as we're going to build them in class, but you won't need to memorize the names right now. You will, however, will need to be able to draw the three-dimensional shape and understand what's going on within it. Here's an image that will depict two different shapes. You see on the left you have ammonia, NH3, and in the center you have your nitrogen, and then you have your three hydrogens attached. The three hydrogens orient themselves this way because there is actually a lone pair of electrons on the center nitrogen as well, and they take up a space just like a regular bond would. So in NH3, you actually have this orientation, which is part of the tetrahedral family, but this one is called trigonal pyramidal. Now in water on your right here has two hydrogens, and it has two electron pairs that again take up space. So you're starting with a tetrahedral family. It looks very much like the NH3, but the bond angle will change slightly, and so this one on your right is called bent. So excuse me, I'm writing in white. This is called bent, and this one is triangular pyramidal. Now, we're going to learn how to name these, but the key thing here to remember is that these electron pairs in both images take up space, and they repel electrons more strongly than bonding pairs, causing the bond angles to change. All right, so to decide the VSEPR theory shapes, we will do that in class in an activity with we're going to build three-dimensional molecules, but here are the names. You can have linear, you can have bent, you can have trigonal planar, you can have tetrahedral, you can have triangular, pyramidal, bent as well again. And then there are several that are in the expanded octet, and they are based on a group called octahedral and triangular, bipyramidal. Okay, so we will see these again in class when we do an activity, and I will give you a better set of notes to go with that.